friends, welcome to Quick Learn tutorial series. In this video, I will explain you instruction set of 8051 microcontroller. This is lecture number 13 of microcontroller series. So let's start with the topic instruction set of 8051 microcontroller. But before I discuss the instruction set, we must know about what do you mean by instructions. So instructions are basically the command which we give to the microcontroller to perform any specific task. So the entire group of instruction is called instruction set, and a set of instruction is also called program. So we can say that instructions written in a program tell the microcontroller which operation is to be carried out. So here the syntax of the instruction is given. In the left hand side of any instruction, opcode is given, and right hand side of any instruction, operand is given. What do you mean by opcode and what do you mean by operands? Opcode is basically an operational code that define or that tell the microcontroller which operation is to be carried out by using this instruction. Operands is given in the right hand side of the instruction. It is a part of instruction that specify data in which operation is to be performed. So in operand, first destination is given and then source is given. Now we know that 8051 microcontroller is basically a 8-bit processor. So the 8051 microcontroller instruction have 8-bit opcodes. So the result of 8051 microcontroller instruction set can have up to 2 raised to the power 8. It means 256 instructions. Now the type of instruction set in 8051 microcontroller. So microcontroller is classified into 5 type of instruction set. First is data transfer instruction. Next is arithmetic instruction. Next logical instruction. Fourth is branching instruction, and last is Boolean instruction. These 5 are the instruction set of 8051 microcontroller. In this video, I will explain all the instruction set one by one. So first is data transfer instruction. As the name suggested, in this instruction, we only transfer data or move data from one location to another location. In this instruction, we do not perform any other operation like addition, subtraction, etc. We do not modify data. We only move data from one location to another location. So, as I have already told, this is the syntax of any instruction. Left hand side opcode is given and right hand side operand is given. The data transfer instruction tells that move the data or copy the data from the source location to destination location. Now, there are 3 types of data transfer instructions. First is move instruction. Next is push or pop instruction. Third is exchange instruction. So one by one I will discuss all the instruction. First is move instruction. In case of move instruction, we move or copy the content of source location to destination location. So this is the syntax of move instruction. Here opcode is MOV, that is move. Here destination location is given and then source location is given. So this instruction tells that move the data or copy the data from source location to destination location. Now, so here I give some example of move instruction. Move instruction support all type of addressing modes. So first example is move Rn, A. Here A is the accumulator register. Rn is the particular register of a particular register bank. So this instruction tells that move the data or copy the data from accumulator register to the Rn register. Now next is the reverse of first instruction. In this instruction, move A, R2, the source location is a particular register and the destination location contain a accumulator register. So this instruction tells that copy the data or move the data of R2 register into the accumulator register. Next instruction is move A, #43H. This instruction is the example of immediate addressing mode because in this instruction, immediate data is given in the instruction itself, and the previous instruction is the example of register addressing mode. So, in this instruction, the third number instruction is the example of immediate addressing mode because hash 43H define it is an immediate data which is given in the instruction. So, this instruction tell that move this immediate data into the accumulator register. When this instruction executed, accumulator is loaded with 43H data. Next instruction is move at the rate R0 comma hash 0E4H. In this instruction, hash 0E4H is the immediate data. This instruction tells that this immediate data is move or copy in a particular memory location whose address is given in the R0 register. Next instruction is move DPTR comma hash 0F2A4H. In this instruction, we transfer or move 16-bit data into a 16-bit register. Here, DPTR is a 16-bit register and the immediate data, which is hash F2A4, is the 16-bit data. So, in this instruction, we move this 16-bit data into the DPTR register. So, one point is to be remembered. In case of data transfer instruction, we copy or move 16-bit data into the 16-bit register, or we copy or move 8-bit data into the 8-bit register or 8-bit memory location. So, these are the move instruction of 8051 microcontroller. Now, other data transfer instructions are push instruction, pop instruction and exchange instruction. So first we know about what do you mean by push and pop instructions. Push and pop, these two are the stack related instruction. Stack is basically a portion of RAM in 8051 microcontroller where we store data temporarily. So if we want to store data into the stack, that operation is called push operation, and if we want to retrieve data from the stack, that operation is called pop operation. So first instruction is push instruction, push direct. This instruction tells that push the data into the stack area. This direct is the memory location from where we retrieve data and push into the stack. Next instruction is pop direct. This instruction tells that retrieve data from the stack area and store in a particular memory location or any register whose address given in the instruction. Next instruction is exchange instruction. Exchange, as the name suggested, here we exchange data between the accumulator register and a byte variable. So these two are the example of exchange instruction. So these are the examples. First example is XCHG A, Rn. This instruction tells that exchange the data of Rn register to the accumulator register, and next instruction is XCHG A, 54H. In this instruction, 54H is a address of a memory location. So this instruction tells that exchange the data from this memory location to the accumulator register. So these are some data transfer instruction of 8051 microcontroller. If you want to study data transfer instruction in detail, so please refer my lecture number 14 where I explain detailed description of data transfer instruction. Next instruction is arithmetic instruction. By using arithmetic instruction, here we perform some basic arithmetic operations just like addition, subtraction, multiplication, division, increment operation, decrement operation, etc. And these arithmetic operations affect the flag registers such as carry flag, overflow flag, auxiliary carry flag in the PSW flag register. So this is the syntax of arithmetic instruction or any instruction. Left hand side opcode is given, right hand side. Now the type of arithmetic instruction. In 8051 microcontroller, there are 24 different instructions under arithmetic group. These instructions are addition instruction. So the opcode of addition instruction is ADD. subtraction instruction, division instruction, multiplication instruction, increment instruction, decrement instruction, and decimal adjust instruction. Here ADD, SUB, DIV, MUL, INC, these are the opcode of given instructions. Now here I will explain some example of arithmetic instructions. First instruction is ADD A, source. 1 or 2 points should be remembered in case of arithmetic instruction. In case of arithmetic instruction, the destination operand should be accumulator register and result always stored in the accumulator register. So, in this case, ADD is the opcode of addition instruction. A and source is the operands. So this instruction tells that add the content of accumulator register with the content of source register and result is stored in the accumulator register. Next instruction is ADD A, 40H. In this instruction, 40H is a memory location. We know that if there is no hash in prefix, so this is the memory location, and if hash 40H is given, so this is an immediate data. So in this instruction, there is no hash present in the prefix, so it is a memory location. So this instruction tells that add the content of accumulator register with the content of 40H memory location and result is stored in the accumulator register. Next instruction is SUBB A, RN. SUBB is the opcode of subtraction. In case of 8051 microcontroller, SUBB is the opcode of normal subtraction and SUBB is the opcode of subtraction with borrow. So for both the opcode is same. So this instruction tells that subtract the content of accumulator register with the content of RN register and result is stored in the accumulator register. And 1 point should be remembered, in case of subtraction, destination data is always subtract from source data. Next instruction is MULAB. This is the example of multiplication instruction. Multiplication and division instruction are different from addition subtraction instruction because in this instruction the opcode is not separated with any comma. We write opcode simply AB. We write instruction MUL AB. In this instruction, A is the accumulator register and B is the B register. So this instruction never change in case of multiplication instruction. This instruction tell that multiply the accumulator data with the data stored in the B register and result is stored in the A and B register both. So this is the example of multiplication instruction. So these are the some example of arithmetic instruction. If you want to detail study of arithmetic instruction, please refer my lecture number 15 where I will discuss arithmetic instruction of 8051 microcontroller in detail. Next is logical instruction. In 8051 microcontroller, there is 25 different instruction under the logical group. So there is total 49 opcodes. In case of logical instruction, auxiliary carry flag and is not affected in any instruction. Only parity flag is affected, but in case of rotate instruction, RRC and RLC instructions, carry flag get affected. So by using this instruction, we perform some basic logical operation just like AND operation, OR operation, XOR operation, NOT operation, etc. These logical operation in 8051 microcontroller perform bitwise between the accumulator data stored in a particular memory location or data stored in a particular register or data given by the programmer. And the result of the logical operation is always stored in the accumulator register. So we can say that in case of arithmetic instruction or in case of logical instruction, the result is stored in the destination location, that is accumulator register. So the type of logical operation is AND operation, OR operation, XOR operation, NOR operation, NOT operation. CLR operation, it means clear operation, complement operation, swap operation, rotate operation. These are the logical operations in 8051 microcontroller. So here I will give some example of logical instruction. First is A and L destination comma source. This instruction is the example of AND logic operation because A and L is the opcode of AND logic instruction. This instruction tells that perform AND logic operation between the source data and the destination data, and result is stored in the accumulator register or destination location. Because we know that in case of arithmetic or logical operation, destination location is always accumulator register. Next is A and L, A comma 40H. This instruction is again example of AND instruction. This instruction tells that add the content of accumulator register with the content of 40H memory location and result is stored in the accumulator register. Next instruction is ORL, A comma RN. This instruction is the example of OR logical operation, and this instruction tells that perform OR operation between the accumulator data and the data is stored in the RN register and result is stored in the accumulator register. Next instruction is XRL A comma hash 10H. In this instruction, hash 10H is the immediate data, and this instruction is the example of XOR instruction. This instruction tells that perform XOR operation between the accumulator data and the immediate data given in the instruction, and result is stored in the accumulator register. Next example is RLA. This instruction is the example of rotate instruction, rotate left instruction. This instruction tells that rotate the content of accumulator left. RRA. This instruction is the example of rotate right instruction. This instruction tells that rotate the content of accumulator right. So these are some example of logical instruction. If you want to detail study of logical instruction, please refer my lecture number 16 where I explain logical instructions in detail. Now next is branching instruction. Branching instruction in 8051 microcontroller change the sequential flow of the main instruction, or we can say that branching instruction are going to alter or change the sequential flow of instruction, or if we want to execute another program in between the main program, that is called subroutine, so we go for the branching instruction. Here I written microcontroller sequentially execute instruction, but in some cases transferring this control to another block of code become essential. So in this time we use branching instruction. Branching instructions are going to change the sequential flow of instruction. Now the type of branching instruction, there are basically three type of branching instruction: jump instruction, call instruction and return instruction. So what do you mean by jump instruction? As the name suggested, in case of jump instruction, we permanently change the content of program counter, or program counter is loaded with the new address of memory location where subroutine is stored, and execute that subroutine, and after execution of subroutine the microcontroller is not coming back to the main program again. Again I will tell you what do you mean by jump instruction. Jump instruction are basically used to change the content of program counter permanently. What is program counter? Program counter is basically a 16-bit register that holds the address of the program memory from where the next instruction is to be fetched and executed. So jump instruction permanently change the content of program counter, or program counter is loaded with the new address of memory location where subroutine is stored, and execute the subroutine and it not come back in a particular main program again. This is called jump instruction. Next is call instruction. In case of call instruction, we temporarily change the content of program counter. What is the difference between jump instruction and call instruction? In case of jump instruction, we permanently change the content of program counter. Whereas in case of call instruction, we temporarily change the content of program counter, or program counter is loaded with the new address of memory location temporarily where subroutine is stored, and execute that subroutine, and after execution of subroutine the microcontroller return back to the main program again. If you want to detail study of branching instruction, please refer my lecture number 17 where I discuss branching instruction in detail with examples. So this video help you a lot in examination point of view. So this video help you a lot in examination. Hope you like the video. For more video, please like, subscribe and share my channel with your friends.